everyone. Today we're gonna have a talk about a woman astronomer, the Astro woman of 1967. What did she do? Well, she discovered the pulsars. She explained to us that we are all ultimately the children of stars. We are all made of the star stuff. We have the star dust in our veins. How could that be possible? How could that can be? Because we are living in this planet Earth and we are using all her stuff. The plants, the animals, all consumes minerals from Earth. From where does this Earth formed? The Earth is formed from the Sun. The Sun is formed from where? The Sun is formed from the remnants of the explosion of many galaxies. And this woman is none other than Dame Susan Jocelyn Bell. Dame is as the same way as Sir Isaac Newton is. It was a great and it was the most excellent order of British Empire. And also, she's a fellow of Royal Society, fellow of Royal Society of Edinburgh, fellow of Royal Astronomical Society, and so on. Seems interesting now. Let's see Bell. And this is this woman, the woman in astronomy. And she is an astrophysicist from Northern Ireland in Britain. It was a small part of the United Kingdom. And she was born in 1943. She discovered first pulsars. Pulsars means the abbreviation for pulsating radio source. And this was one of the most exciting discoveries in astronomy that time. After this discovery, there were a lot of controversies and a lot of newspapers reported this. Here are the pulsars. These pulsars are remainings of the neutron star. Neutron stars mean stars composed of this neutron. The protons and electrons can combine to form neutrons. And these stars are formed out of different chemicals. As an example, if we take sun, the energy from sun is due to the fusion reaction where hydrogen will combine to form helium. This hydrogen can thus be called as a fuel. What happens when these stars run out of their fuel? They explode. Boom. And what will remain is a dense core having superfluous liquids of charges, and they were rotating faster and faster, and they produce magnetic field. This magnetic field emerges through the magnetic poles. As they are rotating, they produce fluctuations in the magnetic field, which in turn produces the electromagnetic waves. These electromagnetic waves are of radio frequency range sometimes, and we can detect this in the radio telescopes. So in figure you can see some of the radio pulses that she observed during her PhD thesis on quasars. But why this is some kind of a pulse? So that they are called as pulsars. For that, let us consider the lighthouse example. That a person is standing in front of a lighthouse, and when the light is facing towards the person so that he can see the light. And what happens when the lighthouse rotates? That means the light rotates but the person standing is there still, so he can't see that light. In a similar way, this pulsar is rotating, and we are only able to detect that light when the magnetic poles are facing towards us. That is one rotation, we get that magnetic poles towards us, shines, we get a pulse, and another rotation, pulse, another rotation, pulse, and these are formed with a period of 1.3 seconds. They found that. And now we can go on a journey on her life. Her father was an architect for the observatory in Armagh in Northern Ireland, and he was an extreme book lover, having a large library with his own collection of number of books. But what impressed her the most is that of astronomy. From the very childhood, she was very interested in science, and she wanted to learn astronomy, and she decided to be a radio astronomer. And also she got a teacher at her secondary level who made her inspired and realized that physics is the easiest subject where one can learn a few concepts and put them together to develop that concept and can make this to develop new ideas and theories and instruments and so on. But that time there was only a few women are interested in science. Most of the women are allowed to only do cookeries or some kinds of stuff that like caring the family and so on. But she wanted to join the science classes, and later she joined in Glasgow University in Scotland, where also she faced male hierarchy in the field of science, and they bullied her. In a society where women were not allowed to work at night, she chose to work in radio astronomy, because the radio waves are not affected by the effect of sunlight, unlike in optical telescopes. And later she applied for Cambridge University, and her passion driven her in the most difficult situations. But she was somewhat caught up with the imposter syndrome, that one feels that like one was not that much valuable. That's one doesn't value oneself. And in Cambridge, she was doing her PhD under Mr. Tony Hewish, as you can see in the picture, on compact objects in space. These are some other kind of objects in space called as quasars, and these quasars are also emitting the radio waves. She worked on radio telescope. These radio telescopes are different from our optical telescope, and this was some sort of dish-like structures within numerous antennas spread over number of acres with a lot of cable wires, and took 2 years of construction itself. After months of observation, she got certain anomalous signals in the chart paper, where the signals are drawn. As usual, for most scientists, she was also avoided from her guide that this must be some kind of interference. But after a lot of controversies, this was found to be new types of celestial objects named as pulsars. And these pulsars drew a lot of newspaper attention, but was just only get into the appendix of her PhD thesis. She also later found 3 more pulsars in the next 2 years also. But after her PhD, that was over, and she left Cambridge. for her marriage. Though she worked more, she was barely rated as scientist as men. But surprisingly, when she was working at the X-ray astronomy, her friends were coming towards her, yelling that the Nobel Prize was awarded that year. And for what work? Yes, that's for Martin Ryle, Mr. Martin Ryle, the then head of Cambridge Astronomy Unit, and Mr. Tony Hewish for pulsars. And this was a prize, as said by her friends, as Nobel Prize, the prize without Bell, the actual discoverer of this pulsar. But the professors are explaining that the Nobel Prize was not what if it is given to a student or a graduate student or a researcher, and it was who inspired the theory, one who inspired her to do this work on this thesis, are the one who is worth that Nobel Prize. And he said that skippers are more important than the crew when you consider a ship. The one who controls the ship is more important than the co-workers of the ship. And this was a huge bone of contention that time, where Sir Fred Hoyle was furious about avoiding the student of them on the discovery of pulsars. Anyway, she was really pleased on getting Nobel Prize for pulsar discovery. And she knew that it was only because she was a graduate student and a woman that she was not awarded that prize, along with the other recipients. Leaving the Cambridge, she worked at other observatories. As we said, the radio astronomy, X-ray astronomy, she worked there. And she is contented for doing some interesting jobs rather than continuing Cambridge and doing some string of prestigious jobs that she might have offered, whether if she had stayed there at Cambridge, and she might have ended up like a narrow-minded person. Now she is having a broad in heart. And later she became the president of Royal Astronomical Society from 2002 to 2004, and the president of Institute of Physics from 2008 to 2010. And in the picture you can see the Royal Astronomical Society towards the left bottom, and also can see the Institute of Physics above it. And in 2018 she had a phone call from Ed Britton, the eminent Princeton physicist, saying that she had won the Special Breakthrough Prize in Fundamental Physics. This was called as the Oscars of Science, and the prize winning was worth $3 million US. What did she do with this money? Whether she used that for her? Nope. She phoned up the chief executive of the Institute of Physics to use this prize money to provide research studentships for people from minorities who want to pursue their career in science, who want to do their PhDs. And he replied positively. He didn't hesitate to accept that money. And she is such a role model for anyone, any women or men who want to pursue their career in science. Though there are a lot of obstacles, you can do whatever you wish to do. And in 2021, she was awarded the Copley Medal, which is an award given by the Royal Society for outstanding achievements in research in any branch of science, and a gold medal of Royal Astronomical Society. And she is a visiting professor of astrophysics at the University of Oxford and a fellow of Mansfield College, the Chancellor of University of Dundee, and so on. She holds numerous honorary doctorates. Right, you can see she holding the Breakthrough Prize, and below there was the trophy of this Breakthrough Prize. And finally, we can see her own words that you can actually do extremely well out of not getting a Nobel Prize. And I have also had so many prizes and so many honors and so many awards that actually I think I have had far more fun than if I got a Nobel Prize, which is a big flash in the pan. You get it? You have a fun week and it's all over. And nobody gives you anything else after that, because they feel they can't match it. This was her own words. And that's it. That's what she did. She had done her career exceptionally, and her exceptional thoughts lead to exceptional actions. And this in turn leads to the way she is right now. So, this was one of the most interesting stories of a woman astronomer, and I think you're all interested in her. And thank you all so much for watching this video. And if you like this video, please hit the like button and subscribe for more updates. Thank you all.